In this lesson, you will learn how to evaluate the simultaneous fulfillment of the two key conditions in project management, finishing on time and within budget. We will use simulation techniques and reverse analysis in Excel to find optimal combinations of schedule and cost that meet a desired confidence level. For example, the 70th percentile. Therefore, we will present the final results to the interested parties of the project. Step by step of the simultaneity process. 1. Enter the target values. Input reference values into the appropriate model cells, for example, target date cell in cell B5 and target budgets in cell B6. Evaluate the combined result. Even if you achieve a 70% probability of meeting the schedule or the cost separately, this does not guarantee a 70% simultaneous success rate. That's because both conditions must be met together and their joint probability is lower. The solution: set a date and use reverse analysis. Fix a desired project completion date in cell B5, for example, August 10th. 2026. Then use Excel's goal-seek function, it's a what-if analysis function, to determine what budget value in B6 will make B16, the joint success probability, reach exactly 70%. This will yield a cost value of approximately $30,900. Upon executing this technique, it is determined that with a budget of approximately $30,900, the project can be completed by August 10th with a 70% probability of joint success, on time and within budget. Now, rerun the simulation using the adjusted conditions of 10,000 iterations, and the results will be on time and within budget, 70%. On time but over budget, 3%. Late but within budget, 21%. And late and over budget, 6%. These results confirm that the selected configuration meets the desired probabilistic contingency level. Now, we introduce the indifference curves. This analysis leads to the construction of an indifference curve, a set of combinations of finish date and budget that jointly satisfy a given confidence level, for example, the 70th percentile. You can build a table of results and graph the combinations that meet the desired level. This is done by selecting multiple combinations and recording whether the model yields the expected joint success. Now, we calculate probabilistic contingency. After running the simulation, we calculate the contingency on the total cost output variable, cell outputs B6, as the difference between the value of the 70th percentile and the mean expected value. We express this difference as a percentage of the mean. So in this example, the 70th percentile value is approximately $31,000. The mean value of total cost is $30,000. The contingency, $1,000 as the difference. And the relative proportion to the mean total cost, 3.6%. This is interpreted as a probabilistic contingency of 3.6% to ensure with 70% confidence that the project finishes on time and within budget. So thanks to this technique, we understand the value of modeling both key project goals simultaneously. We optimize planning decisions based on quantitative analysis, and we visualize equivalent trade-offs using indifference curves.